I am Vandan Gundale, workshop superintendent of the BBIT College. I have, with a great pride, I would like to introduce Professor Gopal Nath Tiwari sir. Professor Gopal Nath Tiwari sir has joined IIT Delhi in the year 1977 after completing his PhD from Banaras Hindu University as postdoctoral fellow and become professor in the year 1997. He has worked in the area of solar thermal and photovoltaic thermal since then with Professor M.S. Soda. He has superintended in June 2016. To his credit, he has published more than 650 research papers with H index of 88. He has also supervised more than 100 PhD students. He has published more than 20 books and 15 chapters of various editing books. His work has been recognized by various agencies in terms of Hariom Ashram Prerit SS Bhatnagar Award, that is ICMR, Bhavnagar, Vigyan Ratna Award, Government of UP, two-time Lifetime Achievement Award, ISAM USA, European Fellow, Faculty Research Award, Career 360, and nominated International Idea Award, etc. Dr. Tiwari is a founder member of Solaris based in UK and organized 3 international and many national conferences at different venues. He has also successfully completed many research projects funded by many ministries, Government of India. He is chief editors and reviewers of many international journals with high impact factor. At present, he is actively looking the ongoing project on GIS PVT funded by PST at his hometown Balia, UP, and also an international joint project with King Saudi University, Saudi Arabia, under the banner of Mag Energy Research Society, for which he is founder president also. He is also involved to open a school for financially weak and good students at Markpur, Chilkar, Balia. Recently, Dr. Tiwari has been world ranked at 449 with C-score of 3.76131963 for Sri Ram Swarup Memorial University, Dew Road, Lucknow, and at 1603 with C-score of 3.34672147 for IIT Delhi among top 2% world scientists from India by Stanford University, UK. The total C-score, if both added, will be 7.1080411, which will improve world ranking significantly. Recently, he has been appointed senior editor of electrical engineering, electronics, and energy elsewhere for a period of 3 years. So we are lucky enough to have such a distinguished personality with us. I welcome Dr. Tiwari sir, and I request him kindly to take out the session and enlighten our participants with his rich experience.
Yeah, I would request Soni sir to first start the presentation, sir. And Tiwari sir, once the presentation is projected,
yes,
then
okay.
yeah.
I will start.
Yes, sir.
Is it visible?
Yeah, that is a blank, I think. Yeah, now it is, I think, started writing the first slides, right? So I should start?
Yeah.
Yeah.
Yes, sir.
Yeah. Good
Yes,
morning.
sir, we can start, sir.
Yeah. Good morning to all the organizing members of this workshop and also the participants who are taking part in this lecture, and I am pleased to be associated with this organization. Now, the today topic of my lecture is greenhouse sustainable technology for rural applications. So first, I want to brief that whatever I have done research at IIT Delhi from the rural point of view, which I am trying at least to transfer that technology in my hometown, Balia district, and the outcome of the project, which I will discuss at the end of my slide. So now this there are few terminology used in my topic lecture: sustainable technology. Any technology is sustainable which does not depend on other electrical sources. Okay, first slide, because I have not completed first slide, so I don't move on the second slide. So now when I say then you move now, and then again the sustainable technology means any technology which is self-sustained. And for the rural applications, actually we need sustainable technology. Now the first term, that is the greenhouse. It is a very, very important greenhouse concept. So first I will go on the definition of the global greenhouse effect. And as we all know, I will not take much time, because without explaining the greenhouse effect, you cannot really be honest to the solar thermal application or solar photovoltaic system as well. So global greenhouse effect, as you know that there are sun and the observer is on the planet Earth. But there is a region that is called the atmosphere, and this atmosphere consists of many light gases which have erupted from within the Earth. And since of the low density, it is suspended between the, you can say, sun and the Earth. That we call the atmosphere. And the gases may be NOx, SOx, carbon dioxide, oxygen, dust, so many things, ozone, other things. These are the gases associated with the atmosphere. And because of that, this atmosphere is also referred as the porous atmosphere. Now, we know that all the parameters which I will discuss is a multiple of 3. So approximate value I have taken near about all these things. For example, the sun temperature is 5,777 Kelvin, but I will define as a 6,000 Kelvin. And similarly, the Earth's temperature, average Earth temperature is 298 Kelvin, but I will define as 300 Kelvin. Now, these are the very important temperature of the sun and the Earth, which is responsible for the existence of all the living organisms on the planet Earth. I will explain like this. For example, there is a Weis displacement law. I think most of the people might be knowing, and if you are not knowing, then you presume whatever I'm saying is correct. That is the product of the wavelength and the temperature is equal to 3000. Lambda T is equal to constant. Now, the sun temperature, if you take the average temperature, black body surface temperature of the sun, it is 6,000 Kelvin. So, if you substitute this 6,000 into lambda 6,000 is equal to 3,000, then lambda will become roughly, not roughly, exactly 0.5 micrometer. So, just see the radiation which is coming from the sun, the average wavelength is 0.5 micrometer. And one thing is important, that any black body emits the radiation, its wavelength varies from 0 to infinity. That's very, very important. Now, when this radiation falls on the top of the atmosphere, what happens? The radiation below 0.3 micrometer and above the 3 micrometer. Below means ultraviolet and above means far infrared radiation. It is blocked by the atmosphere. I am using the word block means it is filters, and only the radiation having the wavelength between 0.3 to 3 micrometer is passed out, are transmitted, are propagated. There are many terms which used. Our interest is the radiation emitted from the sun between 0 to infinity wavelength is only transmitted radiation 0.3 to 3 micrometer. This radiation 0.3 to 3 micrometer, the average wavelength we calculate is 0.5 micrometer. So just see the maximum energy is around 0.5 micrometer. That is available between atmosphere and the earth. Now when this radiation comes, it is of the two forms. That is the direct radiation, which you call the beam radiation, and diffuse radiation. Diffuse radiation has no direction. But for a blue sky condition, the maximum radiation is the beam radiation, direct radiation, which has a direction. So when this radiation having a direction falls on the earth, so as law of the optics says, any rays falling on the surface, some will be reflected. That means part of the radiation is reflected, and the same radiation is also transmitted through the atmosphere. That we call is the albedo. So this is loss as far as our concern is concerned. And after the reflection, only absorption takes place. That means maximum radiation depending on the surface is absorbed by the Earth's surface. Now just see, after the absorption of the radiation, what happens? The Earth's temperature becomes much less than the sun temperature. Let us say about average is 300 Kelvin. Now just see, if you substitute this 300 Kelvin in lambda 300 is equal to 3000, then the lambda will come is equal to 10 micrometer. That means the Earth also emits the radiation between 0 to infinity wavelength, but the maximum energy is associated with the 10 micrometer. Just see, sun emits 0.5 micrometer, which is much lower wavelength than the Earth emitted radiation, that is 10 micrometer. And only because of that, the all radiation coming from the sun is referred as short wavelength radiation. Generally, this is the reason. And all the radiation emitted after the absorption of solar radiation is a long wave radiation. If one has understood this phenomena, then this atmosphere which exists consists of many gases between sun and the earth does not allow radiation of the long wavelength. That means it blocks all the radiation having the long wavelength from the earth to the sky surface. So what happens? That means the role of the atmosphere is trap the solar radiation between the atmosphere and the earth. And this radiation, broadly, sometimes we call electromagnetic waves, sometimes what consists of the ray optics, photon. Because in optics, those who might be studies little bit knowledge of the optics, so there are some law of deflection. Law of deflection is always proved by the considering the variation is electromagnetic waves. So that means the atmosphere trap the solar radiation between the atmosphere and earth. So what happens? Between the atmosphere and the earth, we have the air, which has a very small density. So what will happen? This small density of the air, if gets thermal energy, it is heated. Now screen has gone. Can anybody help to bring the screen? Hello?
Yes, just a minute, sir. Just a minute. We are trying it. Yeah, just a minute, sir.
Anyway, then I'll explain this thing. So what happens? The atmosphere and the Earth's temperature goes high. And if you just go on the literature, when there was no living organism on the Earth, so Earth consists of ice and the flat land. And the temperature of the ice and the Earth got heated. So as you know, if the temperature above the ice heated, then ice starts melting. So after the melting of the ice is formed the water, stagnant water. So here up to this point, I want to say that due to the tipping of the solar radiation between the atmosphere and Earth, the ice of the iceberg has started melting and become the stagnant water. Now, after that, I have the other things to explain. What is the use of explaining? What is the use of explaining this phenomena? Now, just see, water is a stagnant way. So, what happens? As I mentioned you, the solar radiation also consists of the photon, where the energy is equal to E is equal to h nu. H is the Planck's constant, nu is the frequency, and frequency is universal wavelength. So now you can consider this photon carrying the energy is much more than the binding energy of the hydrogen and the oxygen. So now just see, if the binding energy of the hydrogen oxygen is weak, and if photon strikes on the stagnant water, what will happen? There will be deionization of oxygen and the hydrogen, or hydrogen and oxygen. So what happens? The water releases the oxygen to atmosphere. But what about hydrogen? This hydrogen component of the water take the carbon dioxide from the atmosphere and become the hydrocarbon, become the mass, becomes the algae. And now, what is the color of the algae? Green. And the atmosphere is considered as a roof, Earth is considered a floor, and there is a green formation of algae, that is the microorganism is there, living organism is there. Because of whole, you can say the parameter in principle which I explained is referred as the greenhouse effect. House formed by roof and the floor, and since color of the algae is the green, then it's called greenhouse effect. Now, here algae has played a very important role. Now, from the algae, there are many insects coming out of that, but I will not go much detail because it's the biology part. So now I will come to this topic, the greenhouse effect. So the most well-known example of this greenhouse effect is the car. I hope most of the people might be using the car nowadays. In our time, there was not like that. So what happens? The short-wave radiation from the solar energy transmitted by the glass, because glass or any transfer material invented 300 years back, and that plays a very important role as far as use of the solar energy is concerned. But after the transmission from the window of the car, the radiation is absorbed by the seat cover. That means the temperature of the seat cover becomes very small, and if you apply the lambda T is equal to constant, it emits long wave radiation, and the window of the glass trap the solar radiation inside the car, like the atmosphere trap the solar radiation between atmosphere and Earth, and that is called the micro greenhouse effect. Why micro? Global greenhouse effect is the formation of algae, but if a small room, then it is called the
Sir, sorry to interrupt you.
Yeah.
Sir, please, sorry to interrupt you. But now slide is visible, no?
It is visible. It is visible.
Which slide you want now, sir?
Now you can just start from the introduction part.
Is this slide okay? Pardon, sir?
No, earlier,
previous one.
You start from the first slide, so because I have just only explained the working principle. Now just see. So I have explained already, titled the greenhouse sustainable technology for all applications. Next slide. Yeah, next slide.
Just a minute, sir.
Yeah. Just see here. Here also, I have just see here. Now it is not the same problem has happened when I am sharing the.
You need second slide, no sir? Introduction slide you need, no sir?
No, the second slide.
Second slide. This one, sir?
Yeah, that's good.
Introduction slide, no?
Introduction. Now just see, first point I have already explained that, and second is that since I'm going to discuss about the greenhouse for cultivation of the local vegetable medicinal plant. So I will discuss this cultivation in the part as well as the field cultivation. And in that case, why I have considered the different cooling concept? Because if you are growing the crop in the winter, no cooling is required. But when you are going to cultivation in the summer, then cooling is required, which I will discuss in detail. Now, the same greenhouse, which is used for the cultivation of the vegetable, local vegetable, and the medicinal plant, same concept can be used for the aquaculture, because you know the aquaculture means fish production, and fish production during the winter season is goes down. That I will also discuss. Next slide. Now just see, this is a bird's eye view of the solar energy park at IIT Delhi, where passive as well as the photovoltaic system has been installed when I was there. At present, there all this has been dismantled. The PV power mud house, where again solar active PV solar steel, which I will not discuss. Yes, greenhouse aquaculture I am going to discuss. The solar distillation in another topic, where the brackish and hard water is purified. Next. In this solar energy park, we have a complete solar thermal as well as photovoltaic integration. PV standalone system of roughly about 2.4 kilowatt peak, and by using water pumping was there by solar energy. Then the passive building was there, which is called the mud house. Everybody might be knowing that in the old days, all the houses were the mud, and which was more comfortable during the winter season. And the earth air heat exchanger, which I will also list, can be used for heating and cooling. And also the photovoltaic thermal system. Like this concept I have used at the Balia also, and I'll also explain you how improvement we have done for the research which is carried out at IIT Delhi. Obviously, the greenhouse aquaculture and greenhouse dryer and PV street light, all these facilities which I mentioned in this slide was available in Solar Energy Park, which now doesn't exist. Next slide. Next slide. Just see, when I was there in IIT Delhi, then there was a power cut, and particularly it happens during the peak hours when the experiment was going on. By keeping all this concept, we have installed, just say on the back of the person who was showing, there is 2.5 kilowatt peak standalone system, and by using the electricity was supplied to the mud house and also for the water pumping. And the person in between, Professor S.K. Joshi, who was then Director General CSR, who visited because he was knowing that in IIT there is a water pumping. And second important thing at that time was that even water was not available, or you can say the IIT campus, due to the power cut, and because of that many people used to take the water from our park. Next. Because water pumping is also required for the irrigation purpose. Now just see, those who might belong to the rural area, if they might have seen the cultivation of the crop or cultivation of the vegetable, there are mainly the field cultivation is used. And when we talk of the field cultivation, then there is a 2-3 things which you have to take into account. First, if the seeds are very, very small, then the first sowing was done. And after the growth of the sowing, when the plant grew about 2 to 3 weeks, then the transplantation takes place. This is a photograph of the cucumber after the transplantation. And just see, there is a distance between one plant to the other plant. Why there is a distance between one plant and another plant? That the root media of the one plant should not interact with the other plant. Second thing is that in the open field cultivation, there is open irrigation also. And in that case, there is a maximum loss of the water in the form of evaporation, also in the form of the water seepage into the ground itself. So there are two conditions the spacing between the two plants, and second, the open water having the disadvantage of using the water. Next slide. Now just see. So the open irrigation, we have controlled by the drip irrigation. And as I have mentioned you that for the irrigation, because IIT functions during the daytime, so obviously we have to do the drip irrigation during daytime. At that time, there was no, you can see, electricity, and there was no water. So what we have done, we have made an arrangement of the water tank, and this tank was connected to the different pipe, and in pipe there was different holes at the root of each plant. So in that case, you can say that by using the drip irrigation, you can conserve the water. There is no much wastage of the water. Next. This is a greenhouse. I will discuss later on about this thing. Now just see, this slide is a greenhouse is classified by many ways. First, it is based on the shape, and also it is based on the climate. Maybe there is many ways, but I will only discuss on the basis of the shape. This type, even also it is classified on the basis of the cost. In our country, that if you are going to do something new, first question asks whether it is cost effective or not. So you have to keep in mind that your system should be cost effective. So we have done research on the low cost, medium cost, and high tech. So first, this greenhouse is referred to low cost because in this case we have only used bamboo. Bamboo is available everywhere in the, you can say, any part of the country. So bamboo can be molded also. It is called the arc type, you can say this arc shape type of the low cost greenhouse. And it is very easy to fabricate also because carpenter can fabricate. If you know the basic knowledge, then you can have the greenhouse. So that is called the low cost greenhouse. And just see here, plastic is transparent. So in this case also, the short wave radiation, suppose considering the winter condition where temperature is roughly about 5 to 10 degrees centigrade, particularly in the month of the December and January, this temperature goes in the northern part of the country. And if this short wave radiation is transmitted by this transparent plastic, so it will be transmitted because the behavior of the transparent glass is to transmit the short wave radiation. But when it's transmitted inside the greenhouse, inside the room, what happens? It is converted into long wave by after the absorption, as I mentioned earlier. So long wave radiation is emitted by the flow. So what will happen? This plastic does not allow to escape. That means thermal energy, light between atmosphere and the earth, here between the cover and the floor is trapped. And air has a least capacity. So what happens is when a small amount of air is given to the air, it is heated up. That means inside this greenhouse, temperature is higher, much higher than the outside air. This is called the micro greenhouse effect. Next slide. Now just see. It is the modified version of the low cost greenhouse. You can say it is a medium tech. Why? Because GI pipe has been used and only the plastic cover is used. So the area is more than 6 feet by 4 feet. So now here also we can create a temperature inside higher than the outside by greenhouse, micro greenhouse effect. Here you might have seen there is a fan also. Because what happens when the season changes from winter to summer, let us say from February to March, the temperature inside becomes much higher than the outside. In that case, plant can die out. So because of that, you can operate fan, and that fan will extract or throw the hot air from inside to outside. But be careful, this fan needs electricity. And there is no electricity, this fan will not work, and all the plants will be affected, die out. everything should be collapsed. So how we have solved all these problems, I will discuss later on. Next. This is called force mode of sowing. Now just see this shape of the greenhouse is an uneven greenhouse. And in any type of the greenhouse, we need cooling in north part of India. But if you go for Leh, there is no cooling requirement. If you go in Srinagar, no cooling is required. That means if you are designing any solar thermal system for uniform climatic conditions of the whole year, it is very, very cost effective. And for kind information, the energy required for heating is much less than the energy required for cooling purpose. So here in this system, we have incorporated all the cooling arrangement, whether it is a passive or active. But since we need the electricity, so for that we have just integrated inclined roof toward the south of 1.2 kilowatt peak PV system with the storage system, battery and charge for the inverter. That's a different story. So now you can say why inclined? Because the inclined enclosure space can be utilized for the sowing purpose, and after sowing we can transplant into the greenhouse, and also for deep irrigation we can use the electrical from this, and for the cooling purpose, cooling pad and the fan operation, and also we can use the electricity generated by this PV system. And then we can refer, at that time we referred it a self-sustained greenhouse technology. And obviously we are studying in the IIT Delhi, but we say that this concept should be transferred to the rural area where the cultivation can be done during off season. So the return value will be more and the economy of the farmer will increase. So this also a medium tech, because the GI pipe has been used, and the cooling pad, that is nowadays you might have seen, you can see the cooler available in the market where you don't require to change the pad. This is a fiber pad every year. Earlier you used to say every year, but there is a pad which is made of a very good material, which is required the replacement of 5 to 10 years replacement. Next. Just say here in this greenhouse, I have just said this concept is very economical for cold and sunny climatic condition, and the part of the country, Leh, Srinagar, Himachal Pradesh, and Uttarakhand, is now coming under that category because their cooling is less requirement and heating is more requirement. So this greenhouse will be more successful in this area, and it can be cost effective also by cultivating the off-season crop, because summer crop is transported to this area, which becomes very expensive. But there, if we grow the vegetable of the summer crop, so you are already having the winter crop, you can have the summer crop. So all the crop can be available in this area by investing not much, and the greenhouse can be supposed to be proved to be economical. Next. Just see this slide. If you just see this slide, so this is called the pot cultivation. And the advantage, the problem associated with field condition we have solved in this case. Why? Because there is no need to separate the two parts away from each other, because each plant acts independently. So the root media of the one plant is not going to indicate. So for a given space, number of the plant in a pot can be grown much more than the field cultivation. That is the advantage of the pot cultivation. Second, the drip irrigation is most suitable in this case, because you have the pipe and the hole at the root of each plant, so there is not wasted of the much water, irrigated water, like the field cultivation. Third, also I will show you that fertilizer is also conserved in the pot cultivation, because in the field cultivation also there is only 10 to 50% organic farming is utilized, the rest goes to below the ground. And if you remember that in the, or at least in the area, if inorganic fertilizer has been used, so only 10% is used, rest is seepage to the underground water, and because of that, the underground water at the low level available for drinking has been polluted. So we have to go again further deep. So there are three advantages of the pot cultivation. First, the maximum production. Second, deep irrigation, conserve the water. Third, underground water is not polluted by using the pot cultivation. Next. This is after transplantation. Just see this figure. Now we got a project to compare the performance of the pot cultivation and field cultivation. Because suppose you have more number of the pot, but cultivation is affected, so people go field cultivation, why pot cultivation? So this was the main objective of the project funded by the ICR, that what is the effect of on the production by using the field cultivation and pot cultivation. And we have got 20, you can say, pot cultivation. In that case, we have only kept 20 pot. We can keep 30 pot also, because we have to compare. So if number of the plant is the same, you can compare the productivity. And 20 the field. On the right hand side is the field cultivation, left side is the pot cultivation. And we found that the production under same climatic condition, the performance was more or less same. If there is a little bit less performance, because also in this case photosynthesis works, and the principle of the photosynthesis is the same as in the case of the algae formation, because all the plant consists of more than 90% water. And what happens on this plant when the short wave radiation photon falls on the leaf? What happens? This photon isolate water into hydrogen and oxygen, and because of the plant gives the oxygen to the atmosphere, and the hydrogen combine the carbon dioxide from the outside, become the hydrocarbon. And because of that, we always say, everybody knows that the plant gave oxygen for the human being, and the human being discharge the carbon dioxide which is required by the plant. So plants and the human being are complementary to each other. But nowadays, people just become the bhogi when they want to use the oxygen, but they don't want to plant the trees and other parameters. Because tree in the forest comes automatically by seedling. But as far as our across the speed of the human being, you need plantation of the tree, particularly that tree which gives the maximum oxygen. For example, generally, this is my observations, the government put flowers and they say that we have planted 1 lakh tree. It is not like that. Definition of the tree, first define what is the area of the leaf, like burgan, peepal, and pakar, neem, mango, ashoka. All these is supposed to be considered as a tree. Not you can say rose flower and other flowers put, you call it as a tree. No, nothing like that. So unless the human being does not plant, and it is also referred as, अगर हिंदी समझते हो तो कहा जाता है कि एक प्लांट लगाने से एक बच्चे के पालने की बराबर पुण्य मिलता है. ये क्यों कहा गया है? Only because of that, because plant gives the oxygen. And what was the problem of the oxygen? Now corona period, everybody knows this thing. Why? In a city there is only stones of the house. House consists of the stone. पहाड़ है. Plant थोड़ा बहुत लगाने से उससे नहीं plant हो जाएगा जो है. Plant per person is important. This agricultural production means the food production per person is important. Per capita. Why per capita word has come? Because per person, what is the income, what is the consumption, all these are very, very important. There is many, much time can be taken, I will not go on that part. So only in this case, we have compared the pot cultivation and field cultivation. Next slide. Next slide, sir. अब देखिए, अब कैप्सिकम देखिए हमने लोगों ने, we have grown capsicum and just see how capsicum of more or less similar size, more or similar color was available. But even in that case, when I came in Balia, people say that in the greenhouse, if you grow the color, yellow and red color capsicum, return will be more. So now we are doing all these things here. We'll take this thing later on. Next. All this finding was at IIT Delhi. And now just see, when we are going the cucumber, the leaf year starts playing. Why? Because inside greenhouse, we are not allowed outside that has been not to the literature and also digital ICR, IRI, and ultimately found that it is due to the low level of CO2 level during peak sunshine now. So what we have done, we just cow dung cake, we have burned it so that it produces carbon dioxide after 10 a.m. and we found all the yellow color was converted into the green and production was also very started. So also by burning for increasing the level, this is for roof point of view because there is a carbon dioxide sensor also, it is very expensive. So in the rural area, the most important thing is not to buy the thing, but to maintain the thing, to repair the thing. Because of that, I always give the importance, the technique which can be manually managed. So that's how we have managed and we are successful in that case. Next. Just see the cucumber, all this cucumber on the left hand side was greenhouse and the one which was outside, just say the category. All the uniform and the maximum weight of the cucumber on the right side was about 800 grams. And for your kind information, the production was so huge that we cannot sell this outside, but we have distributed and we got the report that the taste of the cucumber was much, much better than at that time locally available. So that was the report which we have got. Next. This is for the tomato, which was in a different season. So control means outside, and we'll say the microcosm left hand side. So now just see the level of the productions by using the same sowing, same transplantation. This is the result. So inside at that time, their tomato was supposed to be available in the summer, not in the winter period. Nowadays, due to the hybrid seed, the tomato and cucumber is everywhere available. Yes, cost varies from time to time, depending on the availability, depending on the weather condition, and all these things. Next. So just see that in the field cultivation, two important parameters are there. Favorable environment above the soil, and second, the nutrition through the root media, means root media composition. And for root media composition, we have prepared 40-40-20, means soil and the sand and the fertilizer, organic fertilizer. And that composition was best because we have tested based on the literature and found 40-40-20 was best. As far as environment is concerned, I think next slide I will show the environment. Can you show the next slide? Favorable environment. Just see. So from plantation, there are four important parameters, just like for the human being. The temperature, first is the temperature. And for kind information, what is my observation is that now body inside temperature is roughly about 37 degrees centigrade. And that 37 degrees centigrade, near about 30 to 37 degrees centigrade, if you can maintain, then the production in the greenhouse for summer crop is sufficient. Second is CO2. For human being, it is 25 degrees centigrade outside, inside 37 degrees centigrade. From plantation, also 30 to 35 degrees centigrade. CO2, as I mentioned, the plant needs CO2 and human being oxygen. the oxygen replaced by CO2 as far as favorable burden. Solar intensity, we also need solar intensity for vitamin D. Vitamin D is also food for us, and the solar intensity for photosynthesis, plant is also required. Just like a human being. Relativity, yes, for relativity, if relativity, the higher relativity is favorable for the plant, but for us, 50% low relativity is required. Just like a human being, comfort range, the favorable environment for the plant is also 4, not more than that. Next. समय हो जाए तो बोल दीजिएगा भाई. Root media, I have already soil composition, I have already told you. And also, next slide. And fertilizer to deep irrigation. We can mix the fertilizer in the water, and we can have the, you can say this conservation of the fertilizer also. Now, I'll just come for the aquaculture fish production. And just see, fish production also requires 4 parameters. And all 4 parameters of fish production is similar to the human being, because the human being moves from one place to another place, fish also moves from other place to other place. But for the fish, water is important. तो बच्चों में पढ़े होंगे कि मैंने मछली को हाथ लगाओ तो डर जाती है और बाहर निकालो तो मर जाती है. So our human being lives in the atmosphere where oxygen is there, but children ask, sir, पानी में कैसे वो oxygen पाते हैं? So since they don't know, the water is consists of hydrogen and oxygen. So there is a mechanism in their fish life. They take the oxygen from the water. And phytochemical formation, that oxygen should also be maintained in the water pond where aquaculture is going on, just like in the greenhouse, you have to maintain the CO2. As far as relative is concerned, water, 100% relativity is there, but also fish, when jump above the water, consume some oxygen from the atmosphere, and relativity also should be there for their comfort. And because of that, if fish has to be transported from one place to other places, it should be in the water, not the dry, because it will die only because of the oxygen, just like a human being. Next. अब देखिए, now we have got another, you can say, the project ICR by using the concept of the how fish can be increased in the winter condition by using the greenhouse effect. So in that case, we have used the common crop. I am not, you can say, using the fish, but my students, Vikas Sarkar, he was from Lisa and from the Agriculture Institute. So he does all these things. So what happens? Because if you want to increase the productivity, so weight and length is not so important. Weight is important. Should be measured at every end of the day. So potassium permanganate, if you put in the water and put the fish on that, it becomes unconscious. And if fish become unconscious, you can measure the weight also, you can measure the length also. Next slide. Just say that is how the potassium magnet was put on the, you can say, this fish to make them unconscious. Next. That is how you can weight the fish. Next. Here is important. Why? Because those who might be using the fish, there's many type of the fish, small fish, big fish. And also each fish require all the parameters which I mentioned. Temperature was one of them. Second, depth of the water is also important. For example, as the fish jumps in the water, the growth is faster. Just like बच्चे नहीं होते, कूदते खेलते हैं, बढ़ते हैं, तो कहा जाता है जितना ही फ्लेक्सिबिलिटी रहेगा उतना ही ग्रो करेंगे. Muscles doctor, but I have seen, I have learned. So here purpose was to see the effect of that on the productivity also. And also the objective was compare the result outside and inside. So we have considered 4 tanks. 2 tanks outside of the different web, and each tank having capacity of 1000 liter. So in the first there was 500 liter and the 1000 liter. Next, we use cylindrical tank which are easily available. Inside greenhouse we have 2 positions. One is above the ground and other is below the ground. So just see, outside tank, obviously temperature of higher water capacity was 1 to 2 degrees centigrade lower because of the storage capacity. And inside, temperature at the underground temperature was 4, 5, 6 degrees centigrade higher than the greenhouse temperature. Why? Because underground, you can say the tank receive the thermal energy from the ground also. Ground is a very important source of the thermal energy, particularly in the winter. So in that case, the underground tank with the greenhouse has the about more than 25 to 30% productivity in comparison to the 500 capacity. But even inside, there was 10%, 15% higher productivity between the above the ground and below the ground. And because of that, if you remember that all the water pond where fish is grown is an underground structure. And even in the winter, it gives some production, but less because the temperature water is exposed to atmosphere. एंड आप ये भी देखेंगे जब गंगा किनारे नहाने जाते हैं अर्ली इन द मॉर्निंग तो टेम्परेचर आप जो है थोड़ा जो है पानी का जो है ज़्यादा पाते, उतना ठंडा नहीं पाते जितना कि स्टोर्ड वाटर होता है, बिकॉज फ्लोइंग होता है तो हीट ट्रांसफर होता है. देयर इज मेनी एप्लीकेशन, आई विल नॉट गो फॉर दैट. अब देखिए हम लोग एक्सपेरिमेंट करना अलग बात होता है, तो बाकी लोग बहुत लोग अच्छे होते हैं जो केवल क्रिटिसाइज करते हैं. दिस आल्सो हैपेंड इन आईटी, पीपल सेइंग दैट इन टैंक यू कैन ग्रो द स्मॉल फिशेस, so you can only take 1 or 2 days fish. What about other days? So we try to make, you can say, the larger pond 6 feet by 4 feet and 6 feet depth, and we use rohu fish, which is growth is very faster. But what happens is this rohu fish also jump above the water level. So by jumping this, they sometimes catch between the pond wall and the greenhouse wall. So in that case, some cat comes and turn the, you can say, this plastic taken away. Sometimes the chowkidar people used to take, they say that I don't know, sir. So it becomes very difficult to watch 24 hours. So why? Because if you are going production of the fish in an open field or in a greenhouse, you have to take the safety for 24 hours. Because in the village I have seen in Banya sometimes fish die out because some people make some, you can say this, mix something, zahirila padarth, pani mein sab fish mar jate hain. Okay. So if this project was not completed, this was not funded by, this was our own IIT funding, so we stopped this. Next. Just see, when we see this study, so what happens, this was a ICR, you can say this institute in Champawat. They have asked to verify the results what we have done. So our was very small level, but here in this case, one can commercialize these things. But unfortunately, the person who was responsible to create so huge, you can say, the pond and similar area with the greenhouse, somehow when the experiment was supposed to start, he was transferred. And after that, the person who took the responsibility, he could not do because he was not knowing ABCD of the fish production. So ultimately, structures remain the same. To the best of my knowledge, after that, what has happened, I am not in touch with that organization. Next. Yes. Just see here. Here only I will just mention the cooling concept, because different level of the cooling is required when we move from summer to winter to summer. So in that case, roof point, it is called the roof vent. Roof vent, if you open whatever by natural way, it is a passive cooling. So heat inside trap can be thrown outside. But if suppose sometimes it fails because of high solar intensity, then we have the arrangement of two fan. So force mode, you need electricity. So you can have one fan, two fan. This is the second cooling concept. Third cooling concept is the cooling pad and the fan. This was in east direction, west direction cooling pad was there, which I have shown in the this earlier figure also. All these needs the electricity, and because of that, we have integrated 1.2 kilowatt standalone system on the south side to feed the electricity to the greenhouse. Next. चलिए तो just fan दिखाया गया था. This is the inside view of the fan. One fan, two fan, and part position. Next. अब देखिए ground collector. This is also IIT Delhi project. Just like a ground, we have dig about 6 inch, put black color, and then the plastic sheet with the wood frame, and connect it to the greenhouse. But what we found that during the daytime, this air collector doesn't keep the heat because the greenhouse temperature was higher than the collector temperature. But in the night time, it was giving very useful information that when the greenhouse temperature becomes lower due to the various losses, so what happens? The earth collector, ground collector was operated by using the fan, and we can maintain the temperature. For kind information, even if you can maintain the temperature 4 or 5 degrees centigrade higher inside, in comparison to outside, at least plant can be survived. So that is how we have done all. We have written paper on all these things available on the literature. Those who are interested, they can go like through the Science Direct, through the Google search, and they can find out. Next. Next slide. Yeah, this is you can say this. If you are in the summer conditions, if you want to reduce the heat flux inside, so jute cloth can be covered between 10 to 2 p.m. because maximum solar radiation comes here. Because you cannot stop whole radiation because photosynthesis is also required. So 10 to 2 in a summer condition. In a winter condition, you can put on the over for whole night. So heat given to the inside by ground collector can be utilized at a maximum level. Next, this is for arc type, manual arrangement of movable jute cloth. This is another, you can same concept during the daytime, peak hours, sunny hour, 10 to 2, in the night, whole time. In the winter, in night time it is covered, during summer, it is daytime it is covered. Next. This is all these views of the sowing is given here and transplantation is there. Next. Local arrangement of the cooling pad. This is the ambassador cooler provided in the best way. It is obviously expensive. Next. Next slide. अब देखिए. Now another application of a greenhouse concept is the drying of the jaggery. As everybody might be knowing that the jaggery is made of juice, cane juice, salt, sea water. So in the monsoon season, it is melted up. So we have got a project that whether this jaggery can be dry and packed so that the cash crop, this is known as, we can store it. So that we did many experiments and ultimately found that the shape and size and thickness is very, very important part. So we have made a different mold, wooden mold, and Western UP have gone to the manufacturer of the jaggery and put here, and we found that the smallest thickness dried faster way than the thicker, you can see. Because in the thicker, to extract the moisture from inside the outside by only conduction. Even in that case, conduction, but small conduction. So it dries faster. And to handle this type of the jaggery is also important. And ISSR Lucknow makes such type of the, they call jaggery biscuit. And the demand of the jaggery biscuit in the Lucknow is very, very huge. Everybody knows, they go buy it, and it is easy to serve to the guests also. So that is how we done it. But the size of the greenhouse will depend upon how much jaggery you want to dry. Next slide, that I will show you. This is a small, you can say this greenhouse we made, and just see the fan is there, and you got the connection from the grid. That's very important. One thing, that all the solar thermal devices gives better performance in the force mode of operation. Why fan? Because moisture is differently transferred outside. If moisture is more, you will feel uncomfort. Drying is less. जैसे मानसून सीजन में कपड़ा देर से सूखता है, but if you dry it will dry fast. So now this experiment we have done with the natural mode as well as force mode. In all our research, we found that force mode is always better than the natural mode. Okay. Next. अब देखिए, अब here I will give some time. As I have mentioned earlier, that you need electricity. One needs electricity for thermal comfort, for human being as well. And for that, I'll just go. In early days, we used to say that there are three most important parameters for the survival of the human being. What was the three parameters? The air, water, and the food. I am talking of 30, 40 years back. Even this is relevant to the rural areas. यहाँ पर लोग अपना जो पेड़ के नीचे सोते हैं, छत के ऊपर सोते हैं, फील्ड में जाते हैं, तो दे गेट क्लीन एयर. एयर उस समय कहा जाता था. उसके बाद नॉमेनक्लेचर बदला क्लीन एयर. वी नीड क्लीन एयर. Then same thing was with the water. Then adjective comes clean water, जिसको बिस्लरी बोतल वाटर बोलते हैं. Then earlier used to organic food, फिर inorganic food. So nowadays we are going to the organic food, organic vegetable we should get. Organic, everything is expensive. Now just see, the philosophy of things changes from time to time. A development जब होता है तो सब कुछ अच्छाइयाँ भी लाता है, कुछ बुराइयाँ भी लाता है. अब now it is coming, fourth important parameter was coming as a electricity. Just say, the बिजली चाहिए, energy चाहिए, power चाहिए. But also there is a parameter called the clean power, clean energy चाहिए. अब clean की adjective चारों parameter पर लग गया to define a thermal comfort of the human being. Why? Why need comfort? Because if you are having a thermal comfort, better thermal comfort, your efficiency will be more, output will be more. But is the output which you are giving then more than the input? जिसको टेक्निकल टर्म में मतलब है efficacy बोलते हैं. Efficiency is different, efficacy is different. Output should be more than input. So input energy invest किए क्या उससे ज़्यादा output आ रहा? All is a very complex parameter. So now question comes that we have underground three fossil fuel mainly available inside the earth. First is coal, second is petroleum, third is the natural gas. Now everybody knows this has a very finite source, and that is how you make a distinction between renewable energy and non-renewable. Renewable energy means the infinite source of energy, like sun. Sun is the basic source of all the renewable energy sources, whether it is a biomass, whether it is a hydro, whether it is a wind, take name of any renewable energy source. And non-renewable means that it has a finite source, like coal, petroleum, natural gas. Now it is well known. अगर आपके पास सीमित पैसा है, सीमित एनर्जी है, वो कभी न कभी खत्म होगा. क्यों? Because your population of your family will increase, population of the state will increase, population of the country will increase, and globally it will increase. There can be question, it can finish within 50 years, 100 years, 200 years. And because of that, now this is a time that people are giving basic research to generate the other energy sources. For example, you might be knowing that the hydrogen, oxygen can be one of the solution. Biogas locally, biogas can be one of the solutions because human population will increase, the cows, animals will increase, dung will be available, kitchen waste, many things are there that is going to be happen. But I will only give some time on solar energy which can produce the electricity. How? Because in early days, 60, 70 years back, we are knowing only three states of the matter: solid, liquid, gas. But later on, we have got semiconductor, that is called N-type material, P-type material. I will not go much in detail. But what is the difference between N-type material and P-type material? The N-type material, electron has the excess, and P-type material holds as a success. But what happens when this N-type P-type material is joined together? So what happens? The electron moves from N-type to P-type material, and holes move from P-type to N material, and they combine at the junction. And that junction is referred as depletion region. Then there was research going on because for a current, you need movement of the electron. If there is no movement of the electron, current will not flow. So, in an NP junction, for a kind information, N-type material is more conducting than the P-type material. P-type material is more insulating than the N-type material. So what happens, since excess electron was in N-type, it is my thinking that the N-type material thickness was less and P-type material was thickness is more. N-type material thickness was in micrometer and P-type material was in millimeter. So two layers was formed and the N-type material was exposed to solar radiation. The same. I have said you that solar radiation is in two forms. One is the electromagnetic wave form and there is the photon form. Just like greenhouse effect I have said there. So greenhouse photon, solar radiation photon is also used in photosynthesis for the crop production. And the similar photon, it falls on the N-type material. So N-type material has a less electrical resistance. So it is transmitted to the depletion region. So what happens? There is a binding energy between electrons and holes. And if it is strikes on the electron and hole and having a more energy, it is isolated. मैंने आयनाइज, ये जिसे कहिए जैसे भीड़ होता है और भीड़ में वहां पर एक थोड़ा सा छोटा सा पटाखा बज जाए तो भगदड़ मच जाती है, अलग अलग हो जाते हैं लोग, उसी तरह से इसमें होता है. आप समझो कि बम्बार्डमेंट वाइज इसको टेक्निकल टर्म दे, when the photon falls and the neutralized electrons at hole, it is separated. That means photon of the solar radiation is responsible to create the excess electron in the depletion region. और इलेक्ट्रॉन्स मूव करने लगता है, पी के तरफ इसलिए नहीं जाता है क्योंकि वो इंसुलेटिंग है, तो इलेक्ट्रॉन मूव करने लगता है, करंट जनरेट हो जाती है। इसी को फोटोवोल्टाइक इफेक्ट बोलते हैं। फोटॉन और पोटेंशियल डिफरेंस हो जाता है, फोटोवोल्टाइक है। शॉर्ट में इसको सोलर सेल भी बोलते हैं क्योंकि इट एक्ट्स एज ए सेल, पॉजिटिव नेगेटिव, और सोलर यूज है, सोलर सेल हो गया। जो डिफरेंट शेप के होते हैं, साइज के होते हैं। जो स्मॉलेस्ट सोलर सेल जो हम लोग मैंने जो जनरली कॉमनली अवेलेबल होता है, उसमें 500 मिली वोल्ट यू कैन से जिस वोल्टेज होता है और करंट 4 एम्पियर के आसपास होता है। तो सीरीज में जोड़ने के लिए क्या बढ़ता है? वोल्टेज बढ़ता है, और पैरेलल में करंट बढ़ता है। तो सीरीज में जोड़ के इसको जो है अब तो पहले उसमें हम लोग इस समय में 36 सोलर सेल था, और जो कि वोल्ट 18 वोल्ट देता था, करंट 4-5 एम्पीयर देता था। A solar cell is also, you cannot have a suspended type. So what happens? There is a rigid plate that is called the Tedlar insulating plate, सफेद प्लेट होता है जो सभी लोग देखे होंगे, और उसके ऊपर उसी साइज का EVA मिथाइल विनाइल एसीटेट होता है, EVA, और उसी के ऊपर सोलर सेल रख दिया जाता है और ग्लास उसके ऊपर रख दिया जाता है और सैंडविच बन जाता है। ग्लास क्यों रखा जाता है? एज आई मेंशन यू, ग्लास ट्रांसमिट शॉर्ट वेव रेडिएशन, और वो जाके आपका सोलर सेल के अंदर करंट प्रोड्यूस करता है, उसको बाहर नहीं जाने देता है, तो गर्म भी हो जाता है। जब ध्यान सुनेगा, आपका जो है फोटॉन जाने से, और नीचे टेलर है, ऊपर ग्लास है, तो इलेक्ट्रिसिटी तो जनरेट होगा, लेकिन गर्मी भी पैदा होगा। तो इफ हीट इज क्रिएटेड आल्सो, तो इलेक्ट्रॉन आपस में लड़ने लगेंगे, कोलाइडिंग टू ईच अदर, तो डायरेक्शन बदल जाएगा, तो आपका करंट की मैग्नीट्यूड इफेक्ट होगा। अब झगड़ा होता है तो आदमी की एफिशिएंसी नहीं कम हो जाती। सिमिलरली इट हैपेंस लाइक दिस। अब देखिए, दैट मींस इफ टेम्परेचर इज मोर ऑफ द पीवी मॉड्यूल, एफिशिएंसी विल गो डाउन। ये नोट करने की चीज है। बट इफ टेम्परेचर गोज डाउन, एफिशिएंसी विल इंक्रीज। तो हम लोगों ने एक रिसर्च किया था आईटी दिल्ली के अंदर, और ये सीएल, सेंट्रल इलेक्ट्रॉनिक्स लिमिटेड, उन्होंने मैन्युफैक्चर किया था कि टेंडर हैज बीन रिप्लेस्ड बाय द ग्लास। तो ऊपर ग्लास हो गया, नीचे ग्लास हो गया, और दो सोलर सेल के बीच में स्पेस होता था। सोलर सेल सर्कुलर टाइप का, एट बिगिनिंग सर्कुलर टाइप का आता था, शूडो आता था, अब रेक्टेंगुलर आता है। तो सर्कुलर वाले में भी स्पेस होता था, शूडो में भी स्पेस होता था। तो उसमें क्या हो जाता है कि नॉन पैकिंग फैक्टर एरिया जो होता था, जहां पर सोलर सेल नहीं होता था, ऊपर ग्लास नीचे ग्लास, तो ट्रांसमिट सोलर रेडिएशन हो जाता था। तो इस केस में क्या हुआ, इसको हम सेमी ट्रांसपेरेंट बोल दिए पीवी मॉड्यूल, या ग्लास टू ग्लास पीवी मॉड्यूल। तो ग्लास टू ग्लास मतलब नीचे भी ग्लास, ऊपर भी ग्लास, और दो सोलर सेल के बीच के स्पेस को नॉन पैकिंग फैक्टर एरिया इज डिफाइंड एज the area of the solar cell divided by area of the whole PV module, and it will be less than 1, but maximum value can be 1। जो रेक्टेंगुलर शेप का है वो मैक्सिमम 1 है, जो है उसमें आप कोई फायदा नहीं मिलेगा, लेकिन इसमें फायदा मिल जाएगा। उसमें फायदा तब मिलेगा जब रेक्टेंगुलर शेप दो सेल के बीच में जगह मिले। So that is called the semi-transparent. This much idea I have given only to explain what is the meaning of semi-transparent photovoltaic system. ये है। और फिर थर्मल कैसे होगा? तो when solar radiation is transmitted to the non-peak effect area, उसके साथ साथ थर्मल एनर्जी भी आएगा। थर्मल एनर्जी टेम्परेचर रेज करेगा, तो इसीलिए सेमी ट्रांसपेरेंट फोटोवोल्टाइक थर्मल ये आ गया। बट इफ सच टाइप ऑफ द सेमी ट्रांसपेरेंट module integrated to the roof of the greenhouse, then it's called greenhouse integrated semi-transparent photovoltaic thermal system. And in this case, the electricity generated by the PV system will be utilized to run the appliances, or even excess electricity supplied to the rural area, where till today we don't get 24 hours electricity supply. So that is the meaning of the greenhouse integrated semi-transparent photovoltaic thermal system. और ये देखिए आपका जो है जहाँ तुम्हारे ख्याल की जितनी चीज हमने यहाँ पर कहा है ये वर्ड्स में लिखा गया है, लास्ट में जो लिखा गया कुकुम्बर, टोमेटो, जो भी फ्रूट्स जो भी लिखा गया है ये ग्रीन हाउस के अंदर किया जाएगा. लेकिन one thing is important, as I have mentioned, that temperatures plays a very important role. So the direct gain is to non-packing area, indirect gain is from back of the solar cell. So you have to optimize the non-packing factor area, or in another way you can say optimization of packing factor for favorable environment inside the greenhouse in terms of the at least temperature. Next slide. अब देखिए, this is the view. It was a layout program we made for Indian condition. It is the direction is given east, west, north, south, also given, and it is also given in south direction. Semi-transparent has been integrated, and also is there is a surface white space where above and below is the glass, and solar radiation can be directly transmitted for photosynthesis. Then also see the black color, that is the position of the solar cell, because solar cell temperature is increased, so heat is conducted below and above. One thing here I want to tell you that if you integrate the opaque PV module, you are not going to get solar radiation inside the greenhouse. But also the electricity generated will be less because temperature will be more, because the solar radiation is step between Teller and glass. Here the operating temperature of the semi-transparent is lower than the opaque. Why? Because some of the radiation is transmitted from one side to other side in the greenhouse, and hence the total thermal energy available between glass to glass is less than the opaque. So there are three advantages. First, its electrical energy is higher. Second, it gives direct as well indirect photosynthesis plus heating the room. Both things is given here. Third, the glass to glass is a very strong component. When there is a harsh weather condition, the canopy cover can be broken out, can be thrown out. But in this case, if the structure is very strong, then it can bear the harsh climatic condition. अब देखिए, हम लोग की तरफ यहाँ पर काम कर रहे हैं, तूफान आता है, टर्नेडो आता है, भले 2 मिनट के लिए आएगा, होल सिस्टम को क्लैश कर देता है. Then it becomes very expensive, and because of that, also some people are not adapting that technology. अगर इसको रूफ पर लगाएंगे, अगर स्ट्रक्चर तगड़ा नहीं रहेगा, तो प्रेशर इतना तगड़ा होता है कि ग्लास को भी तोड़ देता है, which we had experience in Balia district. So my suggestion is that if anyone is interested to install such greenhouse, because it is self-sustained. Now the ground is used for cultivation, and also the ground is used for the power generation. Also the system works against the harsh weather conditions locally available from time to time. So the three advantages. And if the off-season crop is sold in the market at a high price, return is more. If generated electricity is sold, it is also beneficial. Particularly to the government, there is a two type of the system: in the PV system, off-grid system, and online system. Online system means for that you must have 24 hours electricity available on the grid. Why? At least during the daytime, because your system will generate the electricity during the daytime, which should be given to the grid, and when you are import and export meter, so the meter can show you how much excess electricity you have sold, and it will be accounted against your name or account. And in that case, you don't require battery and the inverter. So it is economical as well, because in this whole system, the maintenance becomes expensive only because of the battery and the inverter. Because in the rural area, if you are going to maintain the battery and maintain the, you can say this inverter, they always use the कौन टेक्नोलॉजी बोलते हैं, मतलब कम चलाऊ टेक्नोलॉजी यूज करते हैं वो, बल्कि उसकी इफिशिएंसी कम हो जाती है, सब चीज हो जाता है. तो आई विल एडवाइज दैट इफ इन योर सिटी you have, at least during the daytime, you go on the rooftop, such as the greenhouse, have the grid connection. It is economical. Next. Next. अब देखिए ये जो है आपका जो है 3 सिटी का हम दिखाएंगे आपको. You can say this they are used, but ये कैलिफोर्निया क्या है, सॉलिकल्चर सर फूल वगैरह उगाते हैं उसके लिए बोलते हैं, क्योंकि इट इज आल्सो वेरी एक्सपेंसिव थिंग, सो रिटर्न विल बी हाई. और ये सब आकार शेप वाइज यूज किया गया है. नॉट एवरीवेयर इट हैज बीन यूज, बट दे हैव kept one thing also I will tell you, the even vegetable, the different vegetable require the different level of the solar radiation for photosynthesis. Bottle gourd, लौकी जिसकी बात करते हैं, cucumber, they need more solar radiation for photosynthesis because the number of the leaves, area of the leaves is much more than the other. So these two things require the, so accordingly your non-packing factor area should be optimized. So ऐसा नहीं है कि एक ग्रीन हाउस बना लिया उसमें सभी वेजिटेबल आप ग्रो करेंगे, नो. Also depends upon vertical growth जा रहे हैं कि horizontal growth जा रहे हैं, multi-tier cultivation है कि single tier cultivation है. Accordingly, the exposed glass area, height and the shape, whether you want heating, cooling, then it is designed. ऐसा नहीं है कि हम बलिया जिला के लिए जो डिजाइन किए हैं वो साउथ में वो अप्लीकेबल है, या वो आपका जो क्या कहते हैं श्रीनगर में अप्लीकेबल है. श्रीनगर में other type of the greenhouse may require, depending upon. So design should be made by considering the important parameter like solar radiation, temperature, wind velocity, relativity. All these things should be taken into account. And also one should know the pesticide used from time to time, then it is economical. So in that case, unless you will not have a group consisting of the person at least knowing the basic knowledge, I will not say the depth knowledge, basic knowledge, and the seeds and the pesticides should be available locally, then one can think of that thing. Also, you should know the repairing work of this system is also important. So this will cost, the maintenance cost is very important of making any technology successful. So that is very important. Next. ये लिखा हुआ है नीचे देख लीजिए, वही लिखा है जो मैंने बोला है. अभी देखिए 20 मेगावाट का बहुत लार्ज स्केल है. One thing is important, that population density in India is very huge, even in comparison to the, and population density we talk is called per unit area. That means we are not having the sufficient land for installing the PV system to supply the system to the grid. And because of that, government has given the thesis that everyone should have such type of system on the roof of the building. And very important, the roof of a building is single-story, double-story building can have, but for multi-story building, one should not think of that one, because the area is small and the number of people living in the building is very huge. So it is important before suggesting installing 1 floor, 2 floors in an individual house, you can have at least, you can make 20%, 30%, 50%, you can say. 3 stories up to also you can have, but not 100% depending upon the load required. Load means AC, fan, geyser, mixie, all these things comes under there. So in that case, you can make your creative. कि चटनी अच्छा चाहिए कि ठंडा अच्छा चाहिए, उस केस में आप कर सकते हैं. So you have to compromise if you are going for a 3-story building, because we have the experience of 3-story building and also the multi-story building. Next. देखिए ये आपका जो है स्पेन का है और इसमें all the sides wall are the glass and also the roof is consist of the semi-transparent film module where 200 meters square and be covered. ठीक है. नेक्स्ट अब देखिए यहाँ पर देखिएगा. अब यहाँ पर थोड़ा हम टाइम देंगे क्योंकि मैं भी थक गया हूँ, तो इसको थोड़ा एलिब्रेट करूँगा जो है. We have got a project from Department of Science and Technology through Jamia Millia, and we have 30 kilowatt, you can say this whole system, but here 10 kilowatt having the packing rated capacity 80 watt means packing factor is more. Then 10 kilowatt 50 watt peak, kilowatt peak, watt peak, the packing factor is less, means glass area is more. Then this 25 watt peak, the glass area is much more than that. So basically we have 6 regions here, and in the different region we are having different level of the solar radiation. As far as temperature is concerned, in all the 6 regions there is variation of 1 or 2 degrees. It does not make much difference. In any research, you have to make a difference between the sensitive parameter and the non-sensitive parameter. That's very important. As far as agricultural product is concerned, out of all parameters, I'm not saying the other are insensitive, but within the comparison, the solar radiation is much sensitive because photosynthesis depends on the level of solar radiation. That is very important. Second parameter is the relative humidity. When your temperature is high, relative humidity is 80 and 90%, plant can survive. That's very important parameter. And this greenhouse we have constructed by outsourcing local media. As you know, to work in the rural area is a very tough job. To stay in IIT, to stay in the university campus, the AC, this, that, very difficult. So we have installed this, you can say the system, in the 6 regions. We have chosen 6 crops. 6 crop means bottle gourd, lowkey, cucumber, kheera, capsicum, tomato, French beans, and the broccoli. And all the 6 crops were put in the 6 regions. And what we found that as far as French beans is concerned, this was productivity was more or less uniform across the region. That means not much solar radiation is required for the French bean. Then also the same result was more or less with the tomato. Now, as far as bottle gourd and the cucumber is concerned, it is only give productivity in the region where there is a maximum solar radiation, means the minimum packing factor. And the rest was more or less uniform. There was a difference of only 10% maximum difference as a thumb rule. So that is, and on this case, we just inaugurated this project on February 8. Director, Rajiv Gandhi Institute of Petroleum Technology at ASK Sinha, and here the Vice Chancellor, Jayaprakash Chandra, they visited, and there was also scientist Vijendra Singh, he was a senior scientist from ICAR. So we hold this function, and this is the inside view. We have not yet submitted the reports. I request that this photograph should not be used for your purpose for any references, because I will be the problem. So first, this report should be submitted to DST. Since this lecture is going on, so I said that to talk in the lecture is different thing, but to do in the practice is very difficult phenomenon. In that. Let's Next. Now just see, here again we have used the part cultivation field cultivation. Important is that this land was undeserted land. Undeserted means barren land. Nothing can be grown. So what happens? We have made two systems of growing the first part cultivation. I have just told you with IIT Delhi we have experience of the part cultivation. So root media can be prepared in the part. You can have deep irrigation. Each plant will work independently. The second we have made the channel. about the brick channel, जैसे क्यारी जिसको बोलते हैं, 9 इंच विड्थ का जो है, in all the regions, to just compare which crop grow better in the pot. Here the result was entirely different than what we found. That the bottle gourd and cucumber given the best result in the channel. Why? Because the roots propagate very away, and there is also the distance optimization. It cannot be grown in the pot. Yes, if you have a bigger pot, just like in the IIT Delhi, you can have the cucumber. Here also we have the cucumber, but the जिस पौधे का रूट मीडिया ज्यादा होता है वो आपका जो है रूट मीडिया ज्यादा चाहिए. Like French beans, capsicum, broccoli can be easily grown in the crop. In other words, you can say that अगर height of the vegetable बहुत छोटा 2-3 फीट में है तो part cultivation हमेशा बढ़िया होता है. And then you can also have the multi-floor, multi-tap production. So you can increase the production in that way also. But bottle gourd and cucumber, frankly, is a vertical growth, very high, spread. Their branches are very big. Also, the pesticide in the bottle gourd and the cucumber requires more than the others one. So before this, you just have all this knowledge before going to a such program. And the electricity generated by this, we are supplying to the school where I'm living, and also few people, because other people when we supply, they always want free. Generally, in the rural area, you know how the electricity is fed from the grid, particularly by the farmer or individual or company people. So I don't want to go on this controversy, but unless there is a card system for the supply of the electricity, I think this kind of project will not be beneficial. But here we are going to start the charging of the e-rickshaw, charging of the car. If demands go more, then it is going to be. So it can also be grid connected and off grid connected. Here it is off grid connected. We have the battery system, inverter system. So we have 24 hours electrical supply at our site in Balia. Next. अब देखिए इसमें जो है टमाटो किस तरह का आया है ये आप देख लीजिए, और विंटर सीजन में. और एक चीज मैं आपको बता रहा हूँ जो है, the quality of the tomato which we are getting inside in compared to outside, it was very strong for salad purpose. कट करके बहुत कड़ा होता है यहाँ पर. और there is ये जो आपका डिफरेंट रेड और ये पाइन है, ये डिफरेंट यू कैन से दिस, मतलब जो है समय में फ्रूटिंग हुआ उस वजह से है जो है. लेकिन हम लोग का इम्पोर्टेंस था साइज देखने का. खाने में स्वाद बहुत अच्छा है, इसको हम लोगों ने यूज किया था, चटनी बनाए थे. मेनी थिंग्स यू कैन यूज इट टोमेटो. नेक्स्ट. अब देखिए कैप्सिकम है. कैप्सिकम हम लोगों ने बहुत, कैप्सिकम की प्रोडक्टिविटी मैक्सिमम हुआ था. मतलब जो ये सब पार्ट कल्टीवेशन का रिजल्ट है जो फील्ड कल्टीवेशन में मैंने ये सब नहीं हुआ था. नेक्स्ट. ब्रोकली देखिए, ब्रोकली का साइज मैंने गड़बड़ा गया था जो है, तो इसलिए ब्रोकली को भी रिकमेंड नहीं करते हम. अनुभव नहीं था जो है, वो स्प्लिट कर गया था, बंच के. अगर छोटे छोटे में कट करते तो अच्छा निकलता जो है, तो टाइम क्योंकि ज्यादा हो गया था इसलिए गड़बड़ा गया था. नेक्स्ट. अब देखिए ये ऑन टाइम कुकुम्बर है, कैप्सिकम है, ये सब चीजें हैं. और इस एनर्जी पार्क को जो है हमने अपने टीचर प्रोफेसर MS सोधा का जो जन्मदिन था जो है उसके नाम पर इसको अनाउंस किया था कि सोधा एनर्जी रिसर्च पार्क इसका नाम दिया गया है. और यहाँ पर केवल एक ग्रीन हाउस ही नहीं है, यहाँ पर सोलर डिस्टिलेशन का भी काम है, यहाँ पर बायोगैस भी हम लोग लगाए हैं, यहाँ पर पैसिव कूलिंग कंसेप्ट बाय यूजिंग द मूल इंसुलेशन भी लगाए हैं, यहाँ पर हम लोग एक्वा कल्चर का भी काम करने जा रहे हैं, एंड मेनी मोर्स इट विल टाइम विल कम। और कहाँ से प्रोजेक्ट मिलता है, कहाँ तक जिंदा रहते हैं, सब पर डिपेंड करता है। तो फ्यूचर आई डोंट नो, बट अटेम्प्ट इज दैट वी शुड क्रिएट ए सोलर एनर्जी पार्क in a very unique phenomena, which is also can be a demonstration project, can also be a research project. And I think this is my last slide. और also मैं भी थक गया हूँ, और इस पर क्वेश्चन कोई पूछेंगे तो क्वेश्चन का आंसर देने के लिए कोशिश करूँगा। And you can ask question in solar energy in all area, तो उसमें कोई प्रॉब्लम नहीं है। With that, I will thank again the organizer and the participants who are listening quietly and cooperating with me. Thank you very much. Next last slide दिखा दीजिए।
धन्यवाद सर। सर धन्यवाद
My pleasure, sir. Also,
सर मुझे एक प्रश्न पूछना है।
हाँ पूछिए पूछिए।
सर ये हमारे फार्मर्स जो होते हैं ज्यादातर रेन वाटर पर डिपेंड करते हैं। जब हम ग्रीन हाउस में ये क्रॉप लेने की कोशिश करेंगे तो मतलब रेन वाटर का तो इस्तेमाल नहीं कर पाएंगे ना, उसके तो ड्रिप इरिगेशन की ही जरूरत पड़ेगी इसमें ना।
नहीं 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 सर, नहीं सर, आप गलत सोच रहे हैं।
ऐसा है?
आप देखिए, ऐसा है कि मैं थक भी गया था, स्लाइड भी बहुत हो गया था। ये जितने भी रेन वाटर आपका जो है ग्रीन हाउस के ऊपर आएगा, जरा ध्यान से सुन लीजिएगा, बिकॉज वी हैव यूज्ड द ग्लास, ठीक है ना?
राइट।
तो रेन वाटर हार्वेस्टिंग ऑन द ग्लास रूफ एंड द कन्वेंशनल रूफ इंटायरली डिफरेंट। आप इस रेन वाटर को हार्वेस्ट करेंगे, हम लोग प्रोविजन बनाए हैं, इवन यू कैन यूज फॉर ड्रिंकिंग पर्पज by not having any treatment after 1 or 2 raining. And we have the very, as I mentioned you, we have the aquaculture pond also. So that rainwater can be stored into that aquaculture, and in aquaculture में जो पानी एक्स्ट्रा होता है वो ऑर्गेनिक खाद होता है, उसको आप इसमें इंटीग्रेट कर सकते हैं।
Okay.
तो ऐसा नहीं है कि केवल रेन, अरे इसमें बहुत कंसेप्ट है, मतलब तो इसलिए आप ये मत सोचिए कि रेन आएगा तो बाहर आएगा, अंदर नहीं आएगा। अरे इरिगेशन के लिए पानी चाहिए आपको जो है। यू हैव इलेक्ट्रिसिटी, वी हैव द डीप इरिगेशन सिस्टम, यू इंटीग्रेट दिस एक्वाकल्चर पॉन्ड टू ग्रीन हाउस सिस्टम, दैट्स ऑल, नथिंग एल्स। कोई इसमें प्रॉब्लम नहीं है। और अगर आप देखना चाहते हैं, आइए देखिए, तो यू विल फाइंड हाउ मच वी हैव मेड एफर्ट टू क्रिएट अ सेल्फ सस्टेन सिस्टम। ये सेल्फ सस्टेन सिस्टम नहीं, सेल्फ सस्टेन कैंपस है, सोलर एनर्जी पार्क है। और पूछिए।
Okay, sir. Thank you so much. And one more question. Suppose we have different crops, then design of this greenhouse will be different for every crop, I think. Height and etc.
नहीं, देखिए आप, मैंने आप गलत मैसेज मत लीजिए। जो है हमने ये कहा कि देखिए सभी क्रॉप सभी लोग ग्रो भी नहीं करते हैं, ये ध्यान रख लीजिए। स्मॉल फार्मर जो है वो वेजिटेशन पर ज्यादा जाता है, ठीक है ना? out of vegetation you can choose a crop which can, देखिए डिजर्ट लैंड में हमने किया है, अगर बढ़िया लैंड में रहेगा तो पाट का तो जरूरत पड़ेगा ही पड़ेगा, बिकॉज पाट कल्टिवेशन यू आर कंजर्विंग वाटर, यू आर कंजर्विंग फर्टिलाइजर, यू आर प्रोटेक्टिंग फ्रॉम द हार्श वेदर कंडीशन। तो जैसे हमने बताया कि आपका कैप्सिकम हुआ, आपका टोमेटो हुआ, फ्रेंच बीन्स हुआ, जरूरी थोड़ा कि सभी क्रॉप आप ही उगाएं।
हाँ जी।
आपको बिजनेस करना है तो वह क्रॉप यूज करिए जो आपको मार्केट में ज्यादा वैल्यू दे, मतलब जो है।
करेक्ट।
तो चूंकि अगर मान लीजिए हमको कैप्सिकम उगाना है तो कैप्सिकम हाइट 3-4 फीट होता है, हमारा 9 फीट है, तो 3 टार बना करके मैक्सिमाइज करें, मतलब हमको आमदनी से मतलब है कि हमको टाइप ऑफ क्रॉप से मतलब है।
Yes,
और किसान अगर लौकी उगाना चाहता है तो लौकी के लिए दूसरा वो तो ग्रीन शेड भी यूज कर सकता है, जो मतलब जो है थोड़ा सा एरिया पीवी मॉड्यूल यूज करे, बाकी ग्रीन सिस्टम यूज कर सकता है। See, greenhouse, there are broadly, if you ask my opinion, broadly I classify greenhouse cover in a 3 form. जो नेट ग्रीन आता है ना, उसको भी ग्रीन हाउस बोलते हैं,
Right.
ठीक है ना. दैट इज वेरी इकोनॉमिकल, इजिली अवेलेबल, एवरीवेयर अवेलेबल, ठीक है ना. तो इफ यू वांट टू गो फॉर ब्रोकली, कुकुम्बर, गो फॉर दैट. वन इज अ प्लास्टिक ग्रीन हाउस, ठीक है ना. अब पहाड़ पर जाएंगे तो बहुत हवा चलता है, तो प्लास्टिक मटेरियल 1-2 सीजन में चला गया, आपका इकोनॉमिक आ जाएगा जो है. बट इफ यू वांट टू हैव इलेक्ट्रिसिटी आल्सो, अब जैसे लेह में जाएंगे, लेह में इलेक्ट्रिसिटी प्रोवाइड करना वेरी वेरी एक्सपेंसिव. So we can have such system near the hills where it blocks the air flowing. तो वहां पर बिजली भी पैदा कर सकते हैं, क्योंकि वहां पर जनरेटर यूज करते हैं, पेट्रोल यूज करते हैं. दैट इज पोल्यूशन इन नॉट फ्रेंडली, क्लाइमेट के लिए फ्रेंडली है. सो दैट्स व्हाई आई सेड द डिजाइन एंड द स्टेप depends upon the local weather condition, the requirement and type of the farmer they are going to use it.
Right, sir. Right.
नहीं है मतलब जस्ट मतलब जो है, अब लेक्चर में तो यही सब आ जाएगा, लेकिन जो हम एक्सपीरियंस पाए वो इसी तरह से है.
Thank you very much, sir. Sir, participants, if you have any questions, you can post your question in the chat box. I request participants, if you have any queries or questions or doubts, you can post your questions in the chat box. Sir, we will just wait for 2 seconds, sir.
Sure, no problem.
So I hope there is no further queries.
Okay.
At the outset, I take this opportunity on behalf of our institute BBIT and our FDP team to convey my gratitude to Dr. Tiwari sir. Sir, your lecture was really very informative. We can realize that you have used your engineering knowledge of thermal engineering in real field, sir. It's a real application in the agricultural field. You have touched up many areas like global greenhouse effect, low cost bamboo or can greenhouse, and construction of using local materials, pot cultivation or field cultivation, aquaculture inside the greenhouse, on ground and underground tank in the greenhouse. And you had very nicely explained the greenhouse integrated semi-transparent photovoltaic thermal system, sir. So, sir, thank you so much. You have really enlightened the participants, sir. And once again, I thank you, sir.
My pleasure. Also, thank you all of you.
Thank you, sir.
Thank you very much, sir.
Anurag, sir, you may announce for the next session, sir.
Yes, sir. Yes, thank you, Gundale, sir. Dear participants, we have finished the second session of day 3. We will take lunch break here. We'll break for lunch here, right? And we all will meet at 2:45 at 2:45 p.m. so that we can start our session number 3 at 3 o'clock. Okay, so I request all of you to join at 2:45 p.m. Thank you very much.